Chapter 10, Problem 5. The parametric equations x is equal to 4 cosines of 2t, y is equal to 4 sines of 2t. Trying to find the surface area revolved around the x-axis. And so the formula is 2 pi, integral from a to b. You use y of t because you're going around the x-axis. If you're going around the y-axis, use x of t. And then you have the distance formula, square root of dx dt squared plus dy dt squared. So we're just going to plug things in. So the first thing we need to do is find dx dt. So we look at x, and we use the chain rule to get dx dt to be negative 8 sines of 2t. dy dt, again using the chain rule, we get 8 cosines of 2t. And now we're simply going to replace all the parts in this formula with all the parts we just discovered. So we have surface area is equal to 2 pi. I gave you the interval from 0 to pi over 8 in the problem. Y of t is 4 sines of 2t. And then we have the square root of dx dt, which is negative 8 sines of 2t, that being squared, plus dy dt squared, which is 8 cosines of 2t being squared. And then we do some algebra to get surface area is equal to 2 pi, integral from 0 to pi over 8, 4 sines of 2t, and we square those pieces, they get the square root of 64 sine squared of 2t plus 64 cosine squares of 2t, and that should be giving you a hint of what we're going to do next. So given that part that we had in the previous page, we have inside that square root, we can factor out a 64, leaving 64 sine squared of 2t plus cosine squared of 2t, and from your trig identities, we know that that is 1. So we get the surface area is equal to 2 pi, integral from 0 to pi over 8, 4 sines of 2t, and we get just the square root of 64, which of course is going to turn into 8. We multiply that by the 4, and we get 2 pi, integral from 0 to pi over 8, 32 sines of 2t dt. And bringing that out front, we have 64 pi, integral from 0 to pi over 8 sine of 2t. And we have to have a little baby u substitution here. U is 2t, du is 2 dt. And so we have to put a 2 on the inside, put a half on the outside. So we get 32 pi, integral from 0 to pi over 8, sine of 2t, 2 dt. So we're ready to do our u substitution. Again, on the previous page, we had surface area is equal to 32 pi, integral from 0 to pi over 8, sine of 2t times 2 dt, where u is 2t, du is 2 dt. So we do our u substitution to get 32 pi, integral of sine of u du, which is then negative 32 pi, cosine of u. Bring back our 2t, we have negative 32 pi, cosines of 2t. Evaluate that from 0 up to pi over 8, and you get a final answer of 32 pi minus 16 pi square root of 2.